In this module, we will be discussing placement of concrete and pouring and some of the processes that is necessary to level and to work with concrete. So placement and preparation. First, we're going to be looking at the subgrade and the grade level preparation, getting it ready before the concrete is poured. The objective of this section, you should be able to describe subgrade and grade level preparation, describe the basic subgrade considerations and preparations, describe how elevations and are established, and identify and describe basic foundations. There will be a performance test, and we're going to look at different things we can use to operate a vibrating compactor. We don't have one here, but I will have some videos that you can take a look at to be able to see how it operates and the purpose of using a vibrating compactor and what the compactor is for. Should also we want to check and confirm the elevation of a prepared subgrade those things that we can do. Again, when it's construction, safety comes first. So we need to know the company's safety policies and procedures. And if you're working for a legitimate company, they will have policies and procedures that must be adhered to. We need to wear the proper PPE. We need to stay aware of activity around you. Excavations, which is digging holes in the ground, excavation, moving soil, moving the grade to one place to another, clearing it out. So excavations presents several safety hazards, and formwork and reinforcement components should be stable and reliable. So subgrade preparation. A well-prepared subgrade provide uniform support to a structure above it. And so the most important thing to keep in mind is that when we are using um, uh, concrete as a building material, what's below it is just as important as the concrete. So poorly prepared subgrade can lead to differential sediments. In other words, is that some places might be higher, you might get cracks, you may get concrete dropping to a lower position if it's not done correctly. Let me give you an example real quick. I bought a new house, and each year the um, on my driveway leading to my garage, we call that the apron as you go into the garage, it dropped probably a half inch every year until it was close to 6 to 8 inches. Uh, so to go in the garage, you had to slow down and um, and really push the vehicle up that ramp basically to get into the garage. So I ended up redoing it and making sure that the subgrade was was correct. So most soil consolidates and settles further under a consistent load. And so, in other words, it's important to make sure it's prepared correctly, such as compacting it or using the right materials, uh, uh, part of your subgrade. Some soils expand when wet, even under loads. Uh, Swelling and shrinkage can be destructive to the footing and walls and floors. And again, whole buildings, if you look at a brick house and you see that there's stair steps or cracks in the mortar in the bricks or blocks, it's probably because the foundation is settled and cracked or damaged, and that is a major problem. So proper subgrade conditions or considerations. Construction sites is surveyed, is mapped out, and is planned. And the soil must be tested. It is tested for many different things, from contaminants for number one, but what type of soil is it? if it's sand or is it clay or is it a combination of both, if it's topsoil, I mean, whatever it is, it need to be tested to find out how you're going to prepare it. So reference points when they're taking soil samples, they would take it, they would make some type of grid to take certain samples like every 3 feet or every 5 feet or whatever the distance is, and then take it in different locations um, uh, to transverse that area, going across in different levels to make sure that what's in the ground. So reference points, benchmarks, and elevations are established by a survey crew. So excavations or concrete crew may be expected to do the work and to lay out the things that's on that site. And so they need to know what's there so they can prepare it correctly. So when we're dealing with this diagram, this drawing you see here, you can see some of the issues that may happen if the subgrade is not level. It can cause damage in the concrete. If it's pouring a slab, it'd be weak spots because there's nothing supporting it. So soft spots do not support the slab. And I'm going to tell you, it will shrink. It will cave in. I've seen a, um, a spot of land once, and it was always a divot there, a hole, and it was holding water all the time. And no matter what you did, it was always there, always. And so it took years of filling it in to be able to build it up and to compact it to get it to be stable. So soft spots will not support a slab. Hard spots, such as a buried boulder, can move upward and damage a slab too. So again, well, the ground around it might be soft, but a boulder is hard, and it can cause some shifting and uh, um, uneven stress on the concrete. So when problem soils create uneven conditions, improvements must be made using geotextiles or geogrids and granular type material as a base. As a base. Compacting is the consolidation of soil by tapping it, rolling it, vibrating, and or the application of weight. In other words, using something to take that soft soil or sand and really compacting it down so it becomes very um, as a structure, a solid structure to be able to build on top of. So many times you see large construction sites, especially building warehouses and things. When the excavators come in, a lot of times they're taking some soil out to bring other soil in to be able to which they know what it is, to be able to compact it, and they will spread it out certain depth, and then they would go over and over again just to vibrate and to roll it. And I'm going to show you some of the equipment. I think the next one would be something you see on very large job sites when they're building warehouses. But it's the purpose of it to have a good base. Without a good base, it won't hold up. So increases the stability of the soil by eliminating voids. It can reveal problems that need to be addressed when you're compacting. You're compacting, and next thing you come back and see it's unlevel again. That's just telling you something. You need more of a compacting, more of a base added to it to correct those problems. After excavation, the subgrade is compact with hand tappers, um, portable um, machinery, um, compactors, or heavy equipment. Heavy equipment sometimes is very large piece of equipment that have rollers on it that and it's heavy, and it rolled over back and forth to allow it to compact. So again, some type of mechanized type of equipment that can be used. The hand tampers is just a flat thing. You got some weight to it with a stick on it. You just do it by hand by tapping it down. But they have a mechanized compactor that sits back and it pats back and forth uh, to pat down the soil. But again, just not using soil. A lot of time they would put a base, use some type of granule, like crushed rocks that crush pretty fine to be able to put that down and compact that to give it a solid base. Here's a granule material that is used. It's like crushed rocks, and it could be sand too. But this machinery, basically, what you see there, it will vibrate and rolling those little granule um, uh, indentations, or not indentations, but put an indentation into the ground, but it's compacting it as it rolled over. It's putting that weight in those defined areas. So sand and gravel are not cohesive and need vibrating compaction equipment to be able to do it. And to help it to compact, they use because sand it shifts really easy. But if you add water to it, it becomes more able to compact, that you can join it together. And so cohesive soils mostly composed of materials that holds water, such as clay. Clay is a material that sticks together really tight. Heavy tapping and rolling equipment works best, and the ultimate water content would be between 5 and 8%. Groundwater, if you got a high water table, it can affect how things will cure and how things can shift. And many times, groundwater close to the surface can hinder subgrade and foundation preparation. So drainage towels may be specified and installed outside of the foundation wall, adjacent to the base, to drain the water away. Again, to keep it from having issues. So if you look at this diagram, you can see that the towels around it, it's has crushed stone around it for drainage, but also for keeping the towel from getting that drain towel getting clogged up. So using something that can help shift through the things that can plug up the pores up in that, but allow the water to be filtered at the same time. So using vapor barriers, which is basically some type of plastic membrane to keep moisture from coming into the floor, the concrete. So that is a really good diagram of how to use drain towels and how to um, remove water from the structure. So drain pipes may be, again, specified for the job, but the main thing is to keep water from the foundation. Flowability fill. So controlled low strength material and controlled low strength material. So flowability of the fill. Um, Used in utility cuts, trenches, and similar applications as a backfill or a subbase. Mixture of fly ash, water, and cement can be used, and it does not require compaction. It's very low compressive strength, but self-leveling. It again, it flows really easy, and it's self-leveling because it's so wet. We know water pour it in; it always seeks the same level, and so this is used to give it strength. Matter of fact, basically what we could call it like a slurry mix, and it is used again used in utility cuts. In other words, many times when they're burying things into the um, underground, like utility lines, they would just pour this slurry mix in those trenches and use it uh, to keep from damaging the pipes with things shifting and things like that. So used in utility cuts, trenches, and similar applications as a backfill and a sub base. So it's a structure. So um, to that will solidify and it keep things from shifting. So again, they put in gas lines and the groundwater lines and things that a lot of times that's what they backfill with. Then they put the dirt on top of that. So establishing elevation, several ways to establish dimensions and elevation. Elevation is the height of something. So you could use a builder auto level, a laser level, a hand level, or a string, which will use a level, string level on it. So again, these are different types. A builder auto level is you will look through to sight things out. A laser level, just shooting a laser that you can use, and using a measure to get the height you're looking for. I'm going to see if I can put a video that you can watch to look how to set levels. So this is a builder's auto level. Again, used for sighting things, and we can take measurements and determine. So what you have there is um, a measuring stick, and where that level hits is where you could know how low something is. So you can take multiple. Um, I used to set these and use these when I'm making sure you pour in concrete, put in base in, that everything is level. If you're using a fill, some type of fill to level it out to make sure that when you pour concrete over it or some other things that it is level. So again, a builder's auto level, it sights through the scope to the benchmark. A benchmark is a measurement that you're starting with, what you know. It's a measurement that you want to uh, have everything at. So find your benchmark and determine its elevation. So you rotate the scope and sight uh, on the leveling rod. Hold it vertically at the unknown point. So the difference between the two readings establish the elevation. Um, so of the second point, and because it would be where you're looking at. I'm going to show a video so you can understand how to set this up and how to use it, and we will show you one in the classroom, how to use this builder auto level. A laser level, that's again, you can see this is we'll shoot a laser. It sets the base of the leveling rod on the benchmark. Turn the receiver unit until it faces the transmitter. And so two different components you're using. You're shooting a transmitter, which is sending a signal out. The receiver, it will hits that, um, and you can know where the level was at by using it and finding the mark. So again, this laser would shoot out a beam, and you're using a receiver to receive that to know what your measurements are. He says slide the receiver up and down till you get that intercepts that laser beam. The receiver box will give a steady tone and show a bar when it hits the target. Batter boards in construction, especially in surveying, when you're laying out the building and especially the corners, and you want to know exactly where you set things at, you will build out a batter board. or you have some already made, but you would set these batter boards to find out the corner, the starting point of a corner. So batter boards are wooden stakes and horizontal boards erected 3 to 4 feet outside the edge of the slab. Again, it's outside of the slab, and we are setting some strings to be able to do it. We'll see this in another slide, but understanding what it's used for. So we use a nylon string, and it's stretched tightly, taut, between the batter boards. It forms the forms are placed using the string lines as a guide. So again, you can see these batter boards in every corner. And from that batter board, it's again is stretched out 4 feet from it, so we can actually be able to have room to get around, because we set in a string to find out exactly the layout. So if we need to trench out a garage for the floors, or nor where we're setting our foundation, our walls, we use these batter boards to be able to run a string and set these strings, like I say, very tight, and to find exactly the layout of the structure. So when the slab dimensions are wider than the screed, uh, so what you would do, the immediate elevation points must be established inside the slab. Use a level to transfer the elevations. Okay, so in other words, use a level, a string level, that you can move up and down till you get exactly um, level, so everything is at the right point. So one of the most important things about using batter boards and lining things up to make sure it is square, the corners are square. And a way they can check it is checking the diagonals from corner to corner, diagonally from one end to the other. And if it's a square, they will equal the same distance. So foundations. The chosen foundation depends on the structure and the load imposed on the soil. So a deep foundation includes piles and caissons. Uh, these are used in heavy loads such as tall buildings with basements and those structures on poor soils. So shallow bearing foundations such as those under walls and columns is used for large structures constructed on good, supportive, stable soils. So foundation depth is less than or equal to its width. So in other words, the depth. In other words, is that the foundation is always large, and to support and to span that weight of the walls in the building over a large area. So it's not to dissipate some of that weight in a large space. So per square foot, the weight will be a lot less. So these are certain types of foundations. Uh, a foundation will always have a footing, and a footing is, if you look at these, they pour this first, and this is uh, a pad that is poured, and it's usually at least, well, it's always wider than the walls it's supporting, because it's dissipating the weight over a larger area. So again, we're looking at just a cutaway, but the footing would certainly will be designed to go over a larger space. I'm going to try to draw something to see if we can um, show you what the footing look like. In other words, this is the footing going across the building. Let's see, there you go. And so this is the corner, and of course it goes up. Oops, should be vertical. And so again, if this is the wall, and this footing again would be poured first, and then they would pour the wall on top of it once it cures. And these pieces here is rebarb that is reinforcing, giving strength, giving more tensile strength to that concrete that's supporting those walls. So again, we know that concrete has good compaction, compression strength, but very poor tensile strength. And with the weight of the walls of the building on top of this here, they add rebarb to it. Maybe even the walls will have rebarb too, because the pressure against the grade may be there. So let me erase this. We go to the next slide. Okay. These are different types of footings in these diagrams. So you can see that the footing's there for a reason. It is the main support. It's supporting everything. So constructing foundations. Most concrete foundations do not require finishing. They just pour it and that's it. You don't need to float it out. You don't need to screed it. You don't need to do all these things. It's just put there. And many do not require a form, depending on the type of foundation. Sometimes they could trench it out and just pour it right into the trench, and that becomes the foundation. Um, so because it's buried in the ground, the appearance is unimportant. 4 primary considerations. Soil load bearing capacity should be tested. Um, Reinforcement must be placed per the specifications. Concrete must meet the specific and specified strength, and footings should be sized and positioned according to the plan to provide intended support. Again, never make any changes. If you're building something, and if it's a house or if a building, whatever the architect says to build it that way. So here's some terms we're going to go through for this first section. Angle of repose. That is the sharpest edge related to the horizontal plane at which the sloping surface of the soil, such as the walls of a trench, it remains stable. The maximum amount of slope that a given soil can maintain before it begins to slide or to cave in. Now that is really important because if you're trenching out certain things or you build and doing so, you don't want it to cave in, and that can be very dangerous. And so they would have to shore up those walls so it doesn't cave in. Batter boards is a temporary framing member that help define structure corners and are set at a precise elevation upon which nearby elevations are based on. So in other words, if you pour in let's say um, a garage floor, you want that garage floor level. You don't want one side higher than the other side. So we would set this using batter boards to set uh, the level of that grade and also of the floor. Benching is a method of preventing um, trench cave-ins by excavating the sides of an excavation to form one or more horizontal levels like steps, usually with vertical or near vertical surfaces between each level. So again, benching is the digging out the area so it's not like a vertical wall that can fall in. So benching is like it's almost like a pyramid, upside down pyramid. So in other words, the farther out you go, the wider it becomes. Benchmarks is specific points of reference, typically considered permanent, that marks an elevation. So a benchmark set the main level, or it sets what we use for determining what everything else is going to be built to. Caissons is watertight structures or chambers used for constructing work below water or as a foundation element. So caissons, in other words, that um, trying to use these um, to again as a chamber that can be used. Matter of fact, you can actually, um, well, I'll give you an example. Somebody building a deck in the backyard, and they use these pillars. They will put these cardboard um, uh, tubes into the ground, and for two reasons. One reason is that it would be able to make a nice pier um, uh, and go down to the depth you want it, and you're keeping all the concrete in one spot. But it's basically keeping the concrete in and everything else out. So if there's water or something like that, so caissons is very similar to using those piers, those cardboard piers tubes for building up deck. Differential sediment is the uneven sediment of a foundation or slab, causing the surface to become uneven in response. Differential sediment in a slab can cause sections to settle at different elevations, which is not the way it should be. Flowable fill. Flowable fill. It is the material similar to concrete that is more liquid and used as a self-leveling fill, generally containing fly ash and cement as primary ingredients. The more formal term is controlled low strength material. Or sometimes you hear it may be called other things too, um, a slurry mix. That's basically another thing that you may hear. It's it just pours really easily. Footing, it's a foundation placed on the grade, which is the ground, that transfer all the load weight of a building or another structure. In other words, this is the footing is the main thing. So when you are making sure that the ground is solid, compacted, we put our footings down. The footings is important because it's supporting everything else. Geogrids is the synthetic materials that resist decomposition and are used to stabilize soils, like geotexture tiles that are a porous fabric. Geogrids is more like a synthetic fencing material with similar size openings. And it actually, believe it or not, it works really well. You can put these geogrids down. You can fill it up with really small uh, crush masonry like rocks and things, and it is a hard surface. It doesn't seem like that way, but it holds things together. So geotextiles is a permeable woven, non-woven, or knitted fabric used to improve soil stability and control erosion. Primary control point is a specific point that establishes both a location and an elevation. Shielding, in the context of excavation, is the materials to prevent the trench from collapsing. And again, there's different ways to do it, but it's protection of a person that may be in a trench because it can cave in. Shoring, that's what I was talking about before, that shielding is one way you can do it is shoring. It's in the context of excavation. It refers to the material placed in an excavation that can be adjusted and held firmly in place against the walls of with hydraulics or pneumatic actuators, or using manual screw jacks to prevent the walls from collapsing inward. Shoring and the shielding are terms often used uh, basically synonymously, excuse me, although they are technically different approaches. So again, shielding and shoring is similar, but again, when you're shoring up the walls using uh, like these physical walls to be able to hold back anything that you while you're in that trench working. Surcharge loads is loads applied to the surface of soil close enough to an excavation to create pressure that work against the excavation walls and can lead to their collapse. Examples of soil piles or heavy equipment adjacent to an excavation. So in other words, these uh, surcharge loads is something that shouldn't be there. Somebody parked, you got an excavation and you left let's say a backhoe sitting there. All that weight can cause um, um, the ground to give way and cause a collapse of the walls. A trench box. Again, it's like shoring, but it's a physical assembly of material of walls that you can just drop into a trench and be able to work. So trench boxes is a steel or aluminum brace assemblies placed into a trench or excavation to protect workers from wall collapse. However, note that the trench boxes are not designed to press firmly against the excavations. In other words, the walls are still pushed back. If it collapse, it's going to collapse on the walls, but protect the persons that's inside of the box. So again, when it's trenched out, it is trenched larger than that trench box. Got some questions. Alrighty, vibrating compaction equipment is the best choice for granular soils that are not significantly cohesive. Is that true or false? Vibrating compaction equipment is the best choice for granular soils that are not significantly cohesive. The answer is true. In other words, is that um, they're using granular soils or adding materials to the soil or compacting it. But the vibrating actually helps with the um, compacting the soil, bring it together. And based on, matter of fact, that's one of the reasons why we add the granular soils or the uh, aggregates to the soils to help it to become more stronger. But then again, uh, the the water amount will be less. Batter boards are typically erected blank. Is it A, below the slab form, B, above the slab form, C, 3 to 4 feet outside the edge of a form, or D, at the benchmark location? It is 3 to 4 feet outside the edge of a form. And that's to give you room to move that string around, number one, but also give you room to work until you build your forms. The type of footings that are connected with a strap and used to support multiple columns are called blank. Again, the type of footing that are connected with a strap and used to support multiple columns are called blank. Is it A, standard footings, B, isolated footings, C, combined footings, or is it D, cantilever footings? It is cantilever footings. Cantilever means extending over, extending over.